Hello everybody. In this video I'm going to show you how to dissolve a vector into rectangular components and add them together for a set of vectors in a coplanar system. Coplanar means like they are in the same plane, means like actually 2D cases. Okay, they are working at the same plane, means like they are usually XY plane or YZ plane, whatever you call that one, but at the same plane. Now you already know that we can add two vectors using the force triangle method. But if we have more than two forces, let's say 5, 6 forces or like 3 forces, then basically adding them separately using force triangle would be very difficult and time consuming. So in that case usually we use to dissolve all the forces into rectangular components and then add them together. Okay, now I'm gonna show you how to do that one here. Let's say I have any force F here, in that XY plane, and let's say this angle is theta. Then you can see I can just dissolve that force into two components which are rectangular to each other. Then you can see this one would be F cosine theta, and this one would be F sine theta. So basically I can show that one here. That any particular force, let's say F theta, then I can dissolve that force into two components. One is here, cosine theta, and F sine theta. Similarly, if we have like 3, 4 vectors, then basically we can dissolve all the forces into X and Y components. Okay, and let me show that one, but try to remember that one, that the cosine component is always along the arm associated with this angle here. Okay, the other one is F sine theta. It's not related with like whether it's horizontal or vertical. Okay, it's related with like the arm which is associated with the angle. That would be always cosine. For another example, let me show you. Let's say this is my X and Y angle and I have a force here, R, and I know this angle. Let's say this is theta. So if I want to dissolve that one into X and Y component, then you can see that actually this one is now R cosine theta, because the angle is along with the vertical now. Okay, the angle is with the vertical now, so the vertical one would be cosine theta, and this one would be r sine theta. Now, if I have more forces, then how usually we do that one? And I have, let's say, 3 forces here. Let's say this is F1. This angle is theta. Then I have another force here, which is F2, which is alpha, and one more force here, F3, and let's say this angle is beta. Then basically what we can do, we can dissolve each of those forces, and so this one here is, let's say, F1 cosine theta. This is F1 sine theta. Just for clarity, let me take this one off because I already showed that one here. Now let's say for F2, you can see this angle is with vertical, so this one has to be F2 cosine alpha, and this one has to be F2 sine alpha, sorry. So I can take that one off. Similarly, I can dissolve that one here. This one angle is with x-axis, so this is F3 cosine beta, and this one here is F3 sine beta. Okay, so you can see, actually I will draw that one here. That's F2 cosine alpha. Let me write it down here. Now you can see I dissolve all that forces in such a way that either they are working this direction or this direction. Okay? Now I can say like, hey, the forces in the x direction. So summation of forces in x direction that would be F1 cosine theta plus F2 sine alpha minus F3 cosine beta. Similarly, we can just add or make the summation of Fy in the y direction. Let's say this is positive, x this way positive, y is this way positive. Then we can say this one is basically F1 sine theta minus F2 cosine alpha minus F3 sine beta. Okay, now basically we can show the whole thing like this. This is your x and y direction. So we can show this one based on their sign. Let's say both of them are positive right now, so I'll just show that one like this. This is summation of fx, and let's say this is your summation of fy. So from the parallelogram you can see, or like fourth triangle, whatever you want to do, that this one would be equal to summation of fx squared plus summation of fy squared. So that's the resultant of these three vectors here. And the angle here, theta, you see this one is basically summation of fy. So you can see tan theta is equal to summation of fy divided by summation of fx. So theta is equal to tan inverse summation of fy divided by summation of fx. Okay, that's basically the theory, like how we can add 3 or 4 forces together. Okay, now this is actually the, like the scalar notation, like when you are trying to do that one. We can do that one using the vector notation, means like I, j, k. I is the component in the x direction, y is the component in the y direction, j is the component in the y direction, and k is the component in the other direction. But here actually we are working for 2D cases, so we are expecting only I and j, no k here. Okay, so what we do here, we call that one Cartesian vector. Okay, so let's say this is my x and y, and there is a force here. Let's say this is F. So I can show that one, that my fx is basically f cosine theta, and the y component is basically f sine theta. So we can write that one, that your f vector is basically fx I plus fy j. Okay, so I can express this vector as like fx, which is basically f cosine alpha I plus f cosine theta into j. Okay, so if I have, like, let's say 5 vectors, the 5 force vectors there, then I can express all of them like the Cartesian vector. Then summation of fx means like you have to add all the I components, and summation of y is basically the summation of all the j components. once you get the I components, means like working in the x direction, and if you get the summation of j components, which is basically the summation of fy, then use the same way like that I showed earlier, and you can do the problems. Okay, so if I show you some example, that would be much more clear that what I am trying to say to you. Okay, now let's see some examples. Let's say problem number 36 in your book. Okay, 36, 2-36. So this one is saying resolve each forces acting on the gusset plate into its x and y components and express each force as a Cartesian vector. First of all, they are asking you how to find out the Cartesian vectors. Okay, so let me show that one here. So F1 is working along the x-axis here, and this one is basically F1 is 900 Newton. So if I want to express that one as a Cartesian vector, then you can see F1 is basically 900I. There is no j component here. Okay, so if you take the sign 0, that's basically 0. Okay, so no y component. Now I have F2, which is working 45 degree here, and which is 750 Newton. That's your F2. So you can see my Cartesian vector for F2, that would be 750 cosine theta, means like cosine 45 degree, I, plus, you can see one of these will be this direction, the other one will be this direction, right? So this one will be 750 sine 45 j. So this is basically 530 I plus 530 j. The third force is working here actually. And that's actually 650 here. Rather than giving you the angle, they are showing that one as a ratio. You can see this is kind of like from the Pythagoras formula, that if this one is horizontal is 4, then the vertical would be 3, and the force along that line would be 5. So if this is 5, if the force is 5, the horizontal component is 4 and the vertical component is 3. Okay, so if I dissolve that force here, vertical and horizontal way, then you can see this one would be 3/5 of 650, and this one would be 4/5 of 650. Okay, that's basically so your F3 would be this one, which is 520i. This is actually 520. Minus, because this one is working downward, so you can see 390 J. Okay, so this is just the Cartesian vector for these three forces. Now if you see the next problem here, actually 2-37, that's actually saying that determine the magnitude of the resultant force acting on the plate and its direction measured counterclockwise from the positive x-axis. Actually I'm doing now 2-37. That how to find out the resultant, of the three vectors here. So if you add the three vectors, you can see your resultant would be F1 plus F2 plus F3. Okay? Now, what would be your summation of Fx here? That's actually, you have to add all the I components. So if you add all the I components, then you can see 9 plus 530, 1430 plus 520, so that's actually how much? 1950. Let me do one more time. 5 plus 5, 1050 plus 19, that's 1950 Newton. Okay? Similarly, you just get your summation of Fy. That's basically adding this one minus this one, right? Because this one doesn't have any J component here. So if you subtract 390 from 530, that's actually 140. So both of them are positive. So you can show that one here. So if 1950, that's along here, let's say 1950 Newton, and then we have only 140 here. So your resultant would be just calculate that one. I don't have the calculation with me right now, so you just calculate that one by yourself. And then your theta is basically tan inverse summation of Fy divided by summation of Fx, which is tan inverse 140 divided by 1950. So you just calculate what would be the angle here. Okay, so that's the angle here, theta. So you can either use like your Cartesian vector, or you can just add summation of forces in the x direction and summation of forces in the y direction. But for 3D cases, you will see that we'll do all of them like using Cartesian vectors, because that will be much easier to solve the problems. Okay. Now let's move forward and try to see one more problem from this subchapter so that you can understand them clearly. Okay. Let's try to do problem number 48. Problem number 2-48. Which is saying that I have three forces here. One is F1, one is F2. F2 is 200 Newton. And one force is F3, which is 180 degree or 180 Newton, and the ratio of that thing is 13, 12, and 5. Usually they use that ratio when you can see like these are full numbers based on the Pythagoras formula, right? 12 square plus 5 square root, that would be actually 30, right? So in that situation, if you see the force is 13 here, then the vertical component is 5 and the horizontal component is 12. Okay? Now what this problem is saying, they're saying that three forces act on the bracket, determine the magnitude and direction theta of F1 so that the resultant force is directed along the positive x prime axis and has a magnitude of 800 Newton. Actually they are giving you the magnitude and the direction of the resultant force, but you have to find out one of the force vectors there. Okay, so this force vector is basically F1, and they are saying this is your x prime. Actually the resultant is working here. Okay, the resultant is, let's say, is working here. That's R, and this one is basically 60 degree. So you can see this one is basically 30 degree. And this angle, they are asking to find out this angle here. So I can also write that angle is the angle of F1 is basically 30 minus theta, right? Now if I take the summation of forces in the x direction, okay, let's say summation of forces in the x direction, this is positive, So you can see that actually that's F1 cosine 30 minus theta. This force doesn't have, F2 doesn't have any component in the x direction because this is just perpendicular, okay? And then you can see this one is negative. For horizontal component it will be 12/13 of 180. And that's actually equal to the horizontal component of the resultant, right? So what's the horizontal component of the resultant? So I know this is 800 and this one is making 30 degree with the horizontal, so that would be 800 cosine 30 degree, okay? So if I rearrange that one, then this one would be F1 cosine 30 minus theta is equal to 800 cosine 30. You take this one to the other side, so this one is 12/13 of 180. So that's basically so F1 cosine 30 minus theta, that's actually, if you add this one, that would be 857.97. So that's this is equation number 1. Similarly, you can just do the same thing here for y direction. Summation of Fy is equal to, let's say this is your positive, upward positive. So what you see here, this one doesn't have, actually this one is, let's say 200, but before that, this one I should take the F1 component of that. This is F1 sine 30 degree minus theta, okay, plus 200, and the component of this one in the y direction is basically 5/13 of 180. So if you said that one is equal to the y component of the resultant here, right? So the y component resultant is basically 800 sine 30. So if you rearrange this equation, then you would see F1 sine 30 minus theta would be equal to 130.77. That's your equation number 2. Okay, so what we can do now, let's not erase that one. So I can divide 2 with 1. Okay, equation 2 divided by 1. So you can see F1 sine 30 minus theta divided by F1 cosine 30 minus theta. That's actually 10 sine theta by cosine theta is basically 10 theta. That's 130.77 divided by 857.97. So your 30 minus theta is equal to tan inverse So 30 minus theta, that's basically 8.65. So this one is actually, then you can see your theta is basically 30 minus 8.65. That's actually 21.35 degrees. Okay. So that's your theta. Now if you want to find out if you want to find out your F1, then you can just plug that value theta either here or here, right? So if you plug that value, any one of that, then basically you will get your force F1 869 Newton. So that's the answer here. Okay? So that's the way we usually do like these problems. We don't have that many problems here with 4 or 5 different vectors, because that will be taking much longer time, but basically the method is same. So we'll stop it here and continue this chapter in the next video. Thank you.